episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Merry Christmas to all of you fellow assassins out there. I hope you are all enjoying some time off and getting to spend some quality time with your family. As mentioned last week, this is going to be a continuation of our core modules or clips that I thought that were either funny, insightful, or just overall kind of my favorites from the history of this podcast. And this week, we pick up right where we left off and start by looking back at some of the clips from our conversation that we had with DOS Dude 1. Now, if you haven't listened to that episode in its entirety, the episode is called The Dr. Frankenstein of Macs featuring DOS Dude 1. This was episode 54. It was one of the first episodes in our second season, aka the second year of the podcast. It was probably one of my favorites. There's a lot of good conversations in there, so I could literally just re-air that entire episode and it would probably be good. But I cut out a couple of different clips, so these next couple clips are from that episode. Another thing that you did that I thought was interesting that some of the people listening might know is that that GPU that you added extra VRAM to.
Oh yeah, so that was one of Will's things. This was for an Apple Xserve that he had gotten, and we were trying to find, a GT640 GPU, just a small GPU we could put in this Xserve that would fit in it, that would have a boot screen, be flashable for Mac, and, work in Mac OS. And he got one card initially, and it was bad. Even before flashing it, it didn't work at all. So we ended up getting another one, and the issue with that second one was that the amount of VRAM on the card, 1 gigabyte, wasn't compatible with any Mac ROMs available. They were only for 2 gigabyte cards. So I figure, rather than trying to either modify the video ROM or trying to find another card that already has 2 gigs, we should just try to upgrade it to 2 gigs and then use the ROM for a 2 gig card. And sure enough, that was simple as replacing all 8 VRAM chips, flashing that Mac ROM on there, and it worked perfectly with 2 gigs of VRAM.
Yeah, so if you want to check out that video, he's got it on his YouTube channel. If you search DOS Dude 1 on YouTube, that was a pretty cool video, because I remember when you recorded that video and I watched it, you were like, a friend of mine, has this card, and I was like, oh, I know that guy.
Yes.
Yes. So let's see. Some of the other crazy mods. Probably one of the most well-known piece of software you're known for are your Mac OS patchers.
Yep.
So why don't you walk us through... So I guess the first question has to be is how did you come up with the idea of, one, making the patchers, and two, how did you go about getting them to work so older Macs can run newer versions of Mac OS?
Yeah, so I got into the patches, I've always been into patching later versions of Mac OS on machines that don't support it. But when Sierra came around, and even with El Capitan and Yosemite kind of had a patcher that never really fully worked. But basically there was nobody actually making nice, easy to use, GUI based patching tools. So I was like, well, I like doing Mac development. I like using Objective-C and writing Cocoa applications. So I figure I just use that and gain experience with Cocoa and Objective-C by creating automated patching tools to make installing later macOS versions extremely easy and user friendly. So that's when I made Sierra Patcher, which is my first ever iteration of automated patchers, which nowadays probably isn't the best thing, but back then patching macOS was super simple. It was just a few small files you had to modify, maybe a few kexts you had to copy over from older versions of macOS that did support the hardware that you were trying to support, and it was very, very simple. So I basically was able to do that all on my own, all the patching, everything, and figure out how to patch the installer to bypass all the system checks and modify it and stuff like that. And then I, of course, made a tool that, would create a modified installer. You could run it, run some post-install patches, and then you'd have a later version of macOS running on a machine it didn't support. So that was pretty much how I got started, basically because no one else was doing it, and because I wanted to gain experience with Cocoa and Objective-C.
Because I know I've used some of the patchers before. The Catalina patcher was probably I think probably the best one, and I mean going out on top for sure. That one was super simple. I mean, you didn't even really have to do any post install patches since you got to the point where it was able to not only detect like what system you were using, but also automatically install those drivers itself. So how did you figure out? Did you have to like go into so I guess walk us through the process of how you figured out all the various kexts and drivers and all the other additional support you had to put on these Macs that weren't supported by Apple when making the patchers.
Yeah. So it was all pretty smooth sailing with High Sierra, Sierra, High Sierra, and High Sierra. But when Mojave came around, that added some much increased complexity, and the fact that Apple killed support for all non-metal video cards. Now, while the rest of the patching was pretty simple, like USB patching, audio patching, Wi-Fi card patching, it's basically just small kex modifications. The video card issue was a whole nother tier of complexity in of itself. And that was a team effort between myself and like 2 or 3 other people at the time that were very good reverse engineering people. And at that time, I wasn't like super well versed at reverse engineering, but since then, since the Mojave Patcher days, I've gotten a lot better at it using disassemblers, analyzing assembly, patching binaries, and stuff like that. But that was basically what was required for this to work. We had to make like some wrapper frameworks. Actually, this was more of an issue with Catalina, but I think the same was the case with Mojave, at least to a lesser extent. So we had to figure out how to patch like system frameworks and add basically shim functions to restore functionality that was stripped out of these frameworks when Apple killed support for non-metal video cards. And support for non-metal video cards has always been pretty much a hack, but with Mojave and Catalina, it actually worked pretty well.
And I know that's an issue that OpenCore, the kind of now the more mainstream patcher, they're running into like similar issues with video cards too, aren't they?
And it's basically the same issues, just even more complex. Like with Big Sur, things got way more complex. They completely redid how the installer works. Like they redid that implementation from the ground up, more basing it on how iOS updates are installed and how iOS firmware is installed. So basically, because of that, it made it nearly impossible to patch the installer properly to have it work without OpenCore. And the reason OpenCore is so nice and makes it so easy is because you can simply spoof like the machine model and like basically spoof that it's a virtual machine, which Apple has like special checks for that bypass all the compatibility stuff. So you can literally just tell macOS that the machine is a VM and it'll just skip all those checks and you don't have to patch anything. And then the other issue is with some older CPUs that don't support later instructions like SSE 4.2, you have to patch the kernel to not utilize or not try to call those functions. You have to basically hook any function that would call opcodes that were only in an SSE 4.2 CPU. Otherwise, of course, you get a kernel panic with a invalid instruction. So patching the kernel is pretty much impossible to do. I mean, there are ways to do it, but it's very unreliable and would probably not be useful or work very effectively in like a consumer-grade patcher. So OpenCore also allows you to dynamically patch kernel functions as well. So you can patch whatever piece of code in the kernel that you desire, and it will dynamically patch every system boot, so you don't have to worry about a patched kernel getting overwritten and causing kernel panics that you can't recover from, and stuff like that. So that's kind of why I stopped with the patchers and just delegated that task onto OpenCore Legacy Patcher team, just because it would be so much more robust that way. And they've done a great job with it. So
One of the most infamous issues that Macs have had is the 2011 MacBooks with their dedicated graphics cards, and how fantastic those things are, and how reliable they are, and how they never ever die on you. Uh, so you came up with a couple different ways to fix that issue. Do you want to tell us about some of those and how you came up with them?
So there's a few different iterations with regard to the hardware side of things on that, but the initial thing that had been done previously to any sort of hardware bypasses was using a specific NVRAM variable that luckily Apple was nice enough to implement, that would force the GMUX IC in the machine to default to using the integrated video chipset instead of the dedicated video card. And that was a okay solution, other than the fact that if you reset NVRAM, or if you loaded a copy of Mac OS, which then in turn loaded the AMD video drivers, those changes would get reverted. So the next time you rebooted, it would go back to the dedicated video card, and then you'd have to apply that NVRAM patch all over again to go back, and then it's just a huge pain, and it's not a very good solution at all because of that. Now, what my idea was, why not just bypass the GMUX IC entirely, which is a piece of hardware on the board that handles switching the display output to either use the AMD GPU or the Intel HD graphics on the motherboard. So my first idea was, well, we'll just take wires, like a bunch of baud wires, and just route around the chip. And that worked pretty well, actually, but it had a few issues. A, it was hard as heck to apply that mod. It took a really long time. And B, it had issues with some screens due to lack of LVDS buffering, which was handled by the GMUX IC. And it would cause like lines or artifacting on the screen, not due to the video card, but due to noise in the LVDS interface. My second iteration of that was to take the wires and just create a PCB that you could literally just solder on the board, and it would do all that routing for you, so you didn't have to manually solder wires. And that worked just as well as the wires did, but it was a lot easier to install. Now, the third iteration was a completely new thing that I decided to try, and that is literally just writing custom FPGA code, or hardware description language, or Verilog, whatever you want to call it, for the GMUX IC, which is an FPGA, to make it do what I wanted it to do. And doing this, I was able to A, add the necessary LVDS buffering, B, make the installation super easy. You literally just have to flash the chip with a programmer. And 3, I was able to re-add backlight brightness control to the chip, which was a function that you couldn't get when bypassing it. So, with all that done, that is basically the ultimate solution to fully fixing the 2011 15-inch and 17-inch machines that had a dead AMD video card.
Or I guess the other solution is you could just, if you had a 17-inch one, you could just desolder the GPU and then use that kit that you mentioned earlier and throw a dedicated GPU in there, upgrade the CPU, chump change, easy to
Yeah,
do.
but even in that case, you still have to program the GMUX not to use the dedicated video chipset, because if you do, or if you don't do that, the GMUX IC has no idea the chip's gone, and it's going to try to use it, and it's not going to show anything on the screen because, well, it's trying to use the AMD GPU. So even with that mod done, you still have to apply DMUX, or custom firmware.
Gotcha. Yeah, I mean, I guess that would make sense as far as the chip's concerned, it doesn't know that, other things on the board are being removed. So then when you try to, it's like, just in like programming too, if you try to access something that doesn't exist, program's not happy, or in this case, computer's not happy, and you run into crashing problems.
Yeah.
So as far as all these mods that you do, where do you come up with the idea for some of these mods? Because I know like some of the stuff you do, you'll take like, super old computers. Like I know one time you took I think it was like an iMac G4 or something, and like upgraded the CPU in that, and upgraded the CPU, like soldered CPUs and Mac Minis. And
Yeah.
where do you come up with the ideas for this stuff?
Well, I just kind of think about something that I think might be possible and that sounds fun. So, like, and then I just say, I do a little bit of research, I look at some data sheets, some pinouts, some schematics if I can manage to find it. And then I'm like, well, that looks like it probably would work, so I guess I'll have to try it now and test it. And most of the time, my hunch and everything is correct, and I end up with a successful modification. So, same goes for like RAM upgrades, like CPU upgrades. Like I check to see, is this CPU compatible with this footprint? Does it have the same pinout? Um, can I patch the firmware appropriately so that the machine will boot with this CPU? Because that's a thing you have to worry about sometimes. And eventually, even though it might be pretty difficult, like in the case of that Ivy Bridge upgrade, I do manage to figure something out in the end.
Yeah, I mean, it's just so impressive. Like every time, like I'll see you like drop a new video, and it's just like something completely off the wall that I'm like, how the heck did he one, how did you figure out how to do this? And two, where did you even come up with the idea of how to do this? Since I mean, some of them, I mean, I guess you could kind of like you can see the link between the 2011 and 2012 MacBooks. I mean, with how similar Ivy Bridge and Sandy Bridge is. But then some of the other stuff, I mean, it's just like, what? Again, if you haven't listened to that episode we did with DOS Dude 1, I highly recommend you go listen to it after this one. Again, that episode was called The Dr. Frankenstein of Macs, featuring DOS Dude 1. Now, we've heard of the most infamous line in software development, that being, "Oh, works on my machine." But we haven't heard yet the second most infamous line, which is where our next clip comes from, which comes from the episode Social Media Woes, DBoS, Google Authenticator Security Concerns, Operation Core Dump, and this was episode 55. I think that I have the second most infamous line in all of software development and computer science, which is, of course, only behind, "Oh, works on my machine." And that, of course, being, let me implement this real quick. And, of course, this being this feature, this bug fix, this function, this whatever you're trying to implement. Let me implement this feature real quick, which I think is probably the second most infamous line in all of software development. And I think I am going to refer to this as the big lie of computer science and software development, because I'm seasoned enough to know better. But not only am I seasoned enough to know better, but I'm seasoned enough to know that I know better, which there is a difference. It might not sound really that different, but trust me, there's a difference. The difference is the former, you look back on it and you're like, man, I shouldn't have done that. I know better than that. But the version of I know that I know better is I will be sitting at my computer and I'll be at a pretty good stopping point, I'd say. And I think to myself, oh, let me just implement this feature real quick. And then as soon as I think that to myself, I'm like, don't do that. you know how this ends. This is not going to end well. Don't do it. Yet I still find myself doing it and falling for the big lie. Because on numerous occasions, I'll be writing code and I'll get to a decent stopping point. But the problem is as I write code, other ideas come to my mind of other things to implement. And I'm like, oh yeah, that'll be something I can just knock out real quick. And then of course it's not real quick. So the thing here is what'll happen is I'll check the time and I'll see that I don't have a lot of time left. But there's something I just want to get done real quick, right? So this is generally how it goes when you're telling yourself this lie of let me implement this real quick. So you'll start working on it, and maybe you're actually good and you get it implemented. But then you have this problem where now you're high on the fact that, oh, I got this implemented. Oh, there's this other thing that I can implement real quick. Let me go do that. And then you just like keep going and going and going. And then the next thing you know, like 2 hours have gone by. And you're like, well, shoot, there's other things that I wanted or needed to do. And now you're scrambling just to get all that done. Or the other option, the other option is you're like, oh, let me implement this real quick. And then, you run into some snags along the way, and then again, in like an hour and a half goes by, you're still trying to implement that feature that you thought you'd be able to knock out real quick. And again, you run into the same issue of, you wanted to implement something real quick, and now a couple hours have gone by, and now you're scrambling to do everything else that you wanted to do. Or the other option is you knock out that feature real quick, and then you knock out a second one, or maybe even a third one, and then you get stuck. But the problem is, you don't want to leave it in your code in shambles, but at the same time, you're looking at the clock and seeing the time tick and tick and tick and tick, and there's other things you need to do, but the code doesn't work. Now you're getting mad because the code doesn't work and time's slipping away, and next thing you know, it's like 8 o'clock, you're hungry, you don't have anything in the fridge to eat, you have to cook something, and by this point, it's like 8:30 when you're eating dinner, and the day is gone. There's other things you still wanted or needed to do, and now you're just mad at the world. Does anyone else relate to that, or is that just me going on a rant about how I lie to myself, then get mad at myself because I couldn't implement something and wasted a bunch of my time trying to get something to work? Because I got cocky thinking I could get it implemented real quick, even though I knew I couldn't, because that's just a lie that I tell myself. Software development's fun, guys. If you're wondering, no, that's not the first time that ever happened. No, it's not the last time that will ever happen. And yes, that has happened many times since then. But this next story is another one of my favorites, like the bypassing USB restrictions one. And this is a time when I used Windows XP to hack an email account in order to regain, or I guess hack into, an iCloud account. And this came from the episode Optimizing Your C++ Classes from episode 56. This is a story about how I managed to hack an iCloud account with Windows XP and AOL Desktop. Now, while Windows XP might make it sound like this was from a long time ago, I believe, I actually don't remember the year, but I want to say it was like around 2017-ish, because AOL Desktop was still a thing at this point, but it was in the phases of being like deprecated, end of life, no longer supported, that kind of a thing, which I think was like around 2017 time frame, so it was somewhere in that neighborhood. So that's some context. So basically what happened was my grandmother had some problems with her iPad. And I don't remember exactly the problem she was having, but it was essentially a problem with her iCloud account, and she couldn't sign in to it because she forgot her password. And she didn't have it written down anywhere, so she couldn't log in, that kind of a thing. So they tried to take it to the Apple Store, and because she didn't know the password, the geniuses at the app, and I'm not using that like as a sarcastic way, if you're aware, the people at Apple that like work on like products and stuff and like repair things, they're actually called geniuses, so I'm not doing this as like they're idiots type of a thing. So the people at Apple, they didn't really want anything to do with it because they, just out of the abundance of caution that perhaps this iPad was stolen, because she didn't know the password. And I think she might also not have had the receipt for it too, since I think it was like a gift. So, I mean, no receipt, don't know the password. I mean, if you're in retail, that is kind of a red flag for a device. So, like, I guess it's understandable. So anyway, she couldn't figure out the password, and I had an idea. Because if you never used AOL Desktop, basically what it allowed you to do was allowed you to like more or less auto sign in to like select email accounts. So I had this idea: what if we take her old computer with Windows XP that also has AOL Desktop on it and try to see if we can't get into the email account? Because if we can get into the email account, then we can do a I forgot my password thing to get Apple to send us a link to reset the password. So that's what we tried to do. So we brought her computer home with us from visiting her, and we plugged it in. Sure enough, AOL Desktop was still there, and it hadn't been discontinued yet. It still worked. So we tried to see if we could get on the email account. We could. So we got into the email that we needed to get into. So we're already hacking. We broke into the Windows XP machine. We broke into the email account. We're almost there. We got the forgot password, here's the link to set up a new password email. We got that. So we were another step along the way, but here's where we ran into a minor snag. The snag we ran into was Windows XP obviously was pretty old at this time, and browser support for Windows XP didn't really exist at this point. So we weren't able to actually access the link. So that's where the story ends. Bummer. All right, moving. Just kidding. That's not where the story ends. It continues. So since we have this email, what we did was we forwarded the email to one of, I don't remember if it was like my account or my dad's account, someone's account. We forwarded the email, and then we logged into our email account, and now we have the email that's supposed to be going to my grandma's email account because we forwarded it. We open up the email, reset the password, and bingo bango, we hacked my grandmother's iCloud account. Yep. So that, I guess, in the sense is like hacking for the good, or I guess ethical hacking, or white hat, or however you want to define it. The reason we went out on this hacking expedition was to recover an account for a family member. And obviously we had her permission to do this, so it's not like we were, doing this maliciously or anything like that. But I thought that was just a fun story, that we were able to hack a iCloud account with ancient technology at the time, that being Windows XP and AOL Desktop. One thing I also love about that story is that's really the essence of what real-life hacking is. Now, most people think that hacking is, some guy in his basement with his hoodie and his hood up and the anonymous mask, and he's click-clacking away on the keyboard, typing a bunch of stuff. But in reality, the majority of the time, it's something like this, or some kind of social engineering experiment. It's generally pretty boring. But at the end of the day, it's still a pretty cool story that you said you're able to hack someone. This next clip is another one in the long line of Xserve related clips. This one specifically coming from when I got to play with an Xserve raid. And this episode comes from The 3 Pillars of Account Security, episode 57. You guys know that I love the Xserve. At this point, where else are you going to get semi-regular Xserve content other than here at the Dark Assassins podcast? Because I feel like it's obviously not an every podcast thing, or even like maybe even not even every month thing, but on at least a semi-regular basis, we're talking about the Xserve. So we could potentially even call this heck, I mean, I guess I could make a quarterly podcast called the Xserve Podcast or something. I'm obviously not going to do that, but this is basically, as far as I know anyway, the place if you want some good old Xserve content, because as I'm going to start the tagline: "Long live the Xserve." That's going to be a tagline. So, long live the Xserve. We got some good Xserve stuff here for you. So, I talked in the past when we did that episode a while back about what happened to the Xserve. I talked about the Xserve raid, which the Xserve raid, for those of you who forgot or haven't listened to that episode, which I highly encourage you to listen to, it was a fun episode. The Xserve raid was basically what we call a JBOD, or just a bunch of drives. And basically what it is a chassis that just holds hard drives. That's literally all it does. It just holds a bunch of hard drives. And then you have to hook that up to another computer. In, obviously, the case of Xserve RAID, you would be hooking it up to an Xserve. Now, when I talked about the Xserve RAID, I did not have an Xserve RAID at the time. However, between that episode and today, I managed to acquire an Xserve RAID. I think actually I made that episode, and I'm pretty sure within probably within a month or two, I got my hands on one. Which until this week, I actually hadn't done anything with it. Like I got it, I powered it on to make sure it turned on, and I ran the RAID Administrator app, I think, that Apple made to basically manage the Xserve RAID, but I couldn't actually do anything with it because it uses a technology called Fiber Channel, which is different from Ethernet and SFP and all that good stuff. It looks like an SFP connector, but it's not, because the first thing I tried was plugging it into my switch that I have that has some SFP ports on it, and I figured, I can just plug it in there and I can access it over the network. Yeah, no, that didn't work. It uses a thing called Fiber Channel, which I believe each fiber channel on the Xserve RAID is 2 gigabits per second, so faster than gigabit Ethernet, but obviously not as fast as 10 gig. But I mean, for the time, this came out early 2000s, so I mean, that was pretty good at the time, I would say. But anyway, yeah, because it's literally just taking up rack space, to be honest, which is kind of sad and ironic because I'm out of rack space and I could use more, and there's literally 3 rack units of rack space sitting there literally doing nothing. But at the end of the day, I mean, it looks super cool, so I mean, what are you gonna do? But the thing is, like I mentioned when talking about the Xserve in general, when talking about should you buy it, my answer is obviously no, because it's not practical, because it's, in the Xserve's case, it's pretty slow, it's super power hungry, it's loud as all heck, and it's just not good. Like, if you're looking for a server, first off, there are plenty of better options if you just want a straight up server. But I said, if you just want it for the looks, because it looks cool, then by all means, go buy one. And that's basically the reason why I bought an Xserve RAID. I didn't buy it for the practicality. I didn't buy it for the power efficiency. I didn't buy it for literally anything other than I think it looks super cool. Because, in my opinion, it does. So why am I talking about it now? Well, I recently acquired a Fibre Channel card that coincidentally I didn't actually put in my Xserve, I put in my Mac Pro, and thankfully I still had a install of El Capitan on there, which is what it shipped to me with. Because the Fibre Channel card was not showing up at Ventura, I think kind of for obvious reasons, because I don't believe Fibre Channel is even supported in, I don't know how long it's been since Fibre Channel was supported in macOS, but... So, real quick interjection here. The Fibre Channel actually does work in modern versions of macOS. It just, for whatever reason, didn't show up in the whole, system info about my Mac type thing. But it does work in modern versions of macOS, which I did find out later. But at the time of recording this episode, not this one right now, but the one that you were listening to, I didn't know that at the time. Yeah. But anyway, back to the clip. Obviously, El Capitan had support for it, so I booted into my El Capitan instance, had the card plugged in, took a decent chunk of time getting all the wiring hooked up for the Xserve RAID because I had to get all the cables out of storage, plug everything in, and of course, I wanted to monitor this thing's power draw because I wanted to see just how thirsty this bad boy was, and boy oh boy, it's a thirsty boy, let me tell you. So it is definitely hands down the thirstiest thing I owned because just plugging it in, not even turning it on, just plugging it in, drew 42 watts of power. That's right, 42 watts, not even powered on. So I was like, oh man, this is not good. And if you'll remember, my Mac Pro was, I think, the previous record holder, which I want to say was 3 watts not powered on and 9 watts in sleep mode. So again, not great, but I mean, if you're comparing that to this Xserve RAID, I mean, it's just barely even touching the power. But it gets even better because when I powered that thing on and it roared to life with its fans, which... Actually, I'm not sure I think it's actually quieter than the Xserve now that I think of it, which I guess in fairness isn't that hard to do with how loud the Xserve is, but in all fairness, it was, I think, quieter. And also to its benefit, its fans don't really ramp up that much. They just kind of are always at a static, same level volume, I guess. They don't get super, super loud and then kind of idle down a little bit and then ramp up because, I mean, there's no CPU that it has to cool. So I guess it makes sense. But when it was spinning up all the drives and everything, I clocked it at I think it was a couple watts shy of 600 watts on first boot up. And then, of course, once it idled down, it got down to about 510. Which, for context, that over single-handedly doubled my Home Labs idle power consumption, which is insane. Now, one thing I have to clarify and potentially give credit for why these numbers were so high was the Xserve RAID, at least my model, is equipped with 2 battery modules. And basically the point, which was an additional upgrade at the time of purchase. Obviously, I didn't buy it new, but the one I bought happened to have them. And the reason why these battery modules exist is in the event that the Xserve RAID loses power or for some reason the power gets cut, the RAID controllers on board, their cache can still have power to them from these batteries to basically maintain them. So it's basically an additional level of protection for the data integrity, at least of the RAID cache. So that's why they exist. Now, the batteries, I checked on them in the RAID Administer app thing that for Mac that I was running on macOS Lion, and it showed that they weren't fully charged. Obviously, the thing hasn't been on for literally months, so they were charging up, which I believe part of the power draw, potentially even a large chunk of that 42 watts not even powered on, was going towards charging those batteries. So I'm guessing that if those batteries were actually fully charged, the idle power draw would be less than 510 watts. But again, it still would be probably well over 400 would be my assumption, assuming that was part of the reason why the power draw was so high in general. But yeah, regardless, it is very thirsty. And it also managed to heat up my room so much. It was like borderline uncomfortable. Not borderline. It was uncomfortable upstairs in my server room / office by the time that I got done with it. Which, mind you, it wasn't on for probably more than, I would say, a half hour tops was probably what it was on for. And man, did it heat up that room. Now, as much as I'm kind of bashing on the Xserve RAID for how terrible it is, I will say, when I actually had everything plugged in and wrote some data to it, oh man, guys, seeing the blinky Christmas lights in action of all of those drives lighting up as the data gets written, and those performance lights in the middle going up and down showing the performance, chef's kiss. It was so beautiful. I mean, that is worth the cost of admission right there. That is worth the power draw. Obviously, not all the time, but just something to see. And you can bet that I definitely took a video of that because it was just so beautiful. Now, if I'm being honest with you guys, I'm not actually sure the last time I powered up the Xserve RAID. I probably should do it again at some point here soon, just for the fun factor of it. And probably to recharge those RAID batteries. But it's definitely been a hot minute. This next episode clip that I want to bring to you guys is kind of another fun little one, kind of in combination with the Xserve RAID talking about hard drives, is this idea of computers thinking. And this comes to us from the episode Software Development Meets Physics, episode 62. There used to be a time where we would say the computer is thinking. Now, if you're older, from back in the day, back in like the Windows, I'm thinking like Windows 95, 98 days, maybe even a little before that, maybe even a little after, like Windows XP, but more so the older variants like 98 and 95 or newer, or older rather. At least my family, we used to say that when the computer was taking a bit too long to load stuff, and you would hear that super loud mechanical hard drive clicking noise like this, we would say the computer is thinking. And that was the sound of the computer thinking. And nowadays, if the computer doesn't load something in like 5 milliseconds, you're like, this thing's trash. Get this out of my sight. Or you're like, this developer doesn't know how to code. They made a terrible app. Or, you make all these excuses that if things aren't like done instantly, it's pretty terrible. Which is kind of funny because, back in the day, we weren't spoiled with these fast speeds of internet and SSDs and flash storage and flash drives and, all this speed and whatnot. Back in the day, like, you had your 500 and your 56K modem internet over dial-up and you were happy with it, right? Your computer took like 20 minutes to boot and that was fast. It would take 30 seconds to a minute to open an application and you were happy with it, right? Like nowadays, any of that happens and you're like wanting to get rid of your computer as soon as possible. You're ready to throw that thing out the window and go get a new one because the internet's too slow for you to actually buy a new one online. So you have to get in your car and drive somewhere. And even though that's actually longer, you still do it anyway because it feels quicker than having to wait those couple seconds for a web page to load. You know, I think that clip is probably the epitome of the show notes of these episodes when I say all of this and more on this week's episode of the Dark Assassins podcast, because it's those little tidbits like that that just kind of come out in some of these episodes that I didn't really necessarily plan on per se. I just kind of happened to think of a story or think of a time and just kind of throw it in there for fun. But this next one is kind of this weird world that I live in, talking about having to work at 9 to 5 and code so I can code for fun. And this comes to us from the episode Legitimacy of a VR Future, Software Updates Out the Wazoo, Web Scraping, Operation Core Dump, episode 69. I was thinking this week that how funny it is that I am a professional software developer, right? I write software for a living. I get paid to write software. And in my free time, I also write software, but I don't get paid for it. So I am literally writing code for the privilege to be able to write code. I am getting paid to write code so I can then go in my free time and continue to write more code that I don't get paid for, which I thought was just kind of a fun thought to think of. I guess on the one hand, it's good that I like coding so much because of how much I do of it. Like there are, I kid you not, some days that aside from sleeping and eating, coding is basically all I did all day. And then aside from, the aforementioned walks that I will go on to try to come up with ideas for stuff. Now, this next clip also comes to us from that same episode, episode 69, where I talked about submitting a pull request for Jeff Geerling's top 500 benchmark. Last week I mentioned I was kind of sort of on the fence, but leaning towards yes, of submitting a pull request for the forked repo I made of Jeff Geerling's top 500 benchmark. If you unfamiliar, I have no idea what I'm talking about. After this episode, go listen to last week's episode. I kind of broke it down in basically the changes that I made. But actually, technically, before last week's episode even went live, I had actually submitted the pull request. But as of the recording of this podcast, that is still pending. Now, I mentioned in last week's episode that it's kind of out of my hands. It's not my repo, it's Jeff Geerling's repo. He is totally in his right to ignore it, say no, it's his repo, he can do what he wants. And that's totally cool. But anyone that's interested, on my GitHub, I have the forked version with my updates to it that supports Red Hat-based distributions like Rocky Linux, Alma Linux, Red Hat obviously, Fedora, CentOS Stream, and also Arch-based distros. I tested on Arch and Manjaro. Not that you would be running like a server with Manjaro, but if you're running Manjaro on your system and wanted to do the benchmark locally, I guess it works. So if anyone's interested in that. So now I'm basically kind of in the waiting game. But it was, as far as the pull request process itself, it was actually super easy. Really all I did was I forked his repo, pushed my changes to the forked repo, and then there was like a thing on GitHub that said like I think it was 6 commits ahead of Jeff's master branch. Would you like to open a pull request? And I hit yes. And then it kind of prompted me gave this prompt of like the title and a description, basically like, kind of headline, like what you changed, and then the description kind of describe what you changed. So aside from like, doing a little write-up of, the things I changed and whatnot, it was pretty simple. And then I, submitted the pull request and then began the waiting game. And I didn't have to wait too long because that is where our next clip comes from just a couple episodes later. This is where I did finally get those changes merged into Jeff Geerling's repo. And this was from the episode titled Apple Dominates Headlines, Contributing to Open Source, Home Lab Push Notifications, Operation Core Dump, episode 72. Well, if you followed along on GitHub this week, you would see that there is a new contributor listed on Jeff Geerling's Top 500 benchmark because my pull request got accepted and merged into his mainline branch, which I was very happy to see. We did have a little conversation back and forth. Not all the changes that I made actually got merged in. So basically what happened was he was thinking of potentially moving away from Atlas, which Atlas was the linear algebra, one of the tools that was being used as a part of this benchmark. And part of the issue that I ran into when using it was using deprecated or outdated and no longer supported system calls, specifically fgrep, and that would output a warning message, and that was basically completely messing up the output of the program, so it couldn't accurately read the system's specs and all that good stuff. So I had to write three patches to patch the Atlas software in order for it actually to configure properly and then build and install itself, and for the benchmark to be able to run on newer Linux systems that had newer versions of grep. I did an entire episode covering all of this, so if you're completely new and wondering what the heck I'm talking about, a couple episodes back I did an episode covering this entire saga and went in more detail into the patches themselves, but that was just kind of a quick recap to get people back up to speed. So he was kind of thinking of potentially moving away from Atlas into using another piece of software, and he's currently looking at, I forget the two off the top of my head, but he's looking at a couple other options. And the thing he mentioned to me was he wanted me to split the Atlas patch into its own pull request, so he wouldn't, merge this patch in only to then have to remove it if he decides to go with another, linear algebra library or whatever, and basically get rid of Atlas, which I completely understood, made complete sense to me. Now, the nice thing was, because I already had all the work done and how I wrote the playbook that handled the Atlas patch, literally all I had to do was remove 2 tasks from the playbook, and that was literally it. Because I had one task that basically that checked the package versions that you had installed on the system, and then based on the package version of grep, it would then include or ignore the stuff for the Atlas patch. So I literally just removed those 2 things, and that was it, because the stuff for the Atlas patch was in its own separate file. So it made it super easy to basically make 2 different pull requests for it. Literally all I did was took the current state of my repo that had both the Atlas patch and the updated support for other operating systems, and then made a new branch from the current state, removed those 2 tasks and that other file, that being the Atlas stuff, and then pushed that to the master branch, and then that updated the pull request for adding support for new operating systems. And then I pushed the new branch that I made, which was literally just what it was before I took out the stuff for Atlas, pushed that to a new branch on my repository, and then opened another pull request from that branch, and bada bing, bada boom, we're good to go. So shortly after that, he approved the pull request, got it merged into his mainline branch, and it honestly felt pretty good to be merged in there. And like I said, when I first started down this path, I wasn't really doing it to contribute. The main thing I wanted to do was I wanted to, obviously have more support, because I wanted to be able to run this on other operating systems aside from just Debian-based systems. And I had a feeling there was probably other people out there too that probably fell into the same category as me. So I thought it'd be cool to be able to help out the community and add more support for it. And when Jeff finally responded to the initial pull request, like, he was totally all for it, like adding the additional support and whatnot. Yeah, Jeff's still working it out, potentially what to do with Atlas. So either he comes up with a new solution and the Atlas patch is obsolete, which is probably for the best in my opinion, or he inevitably decides that Atlas is going to stick around and then includes that patch in the future. But again, we'll see what happens. So since we have the luxury of being in the future, we do know what happens. And Jeff ended up going with different linear algebra approaches, thus basically rendering the Atlas patch useless, which, to be honest, was, like I mentioned in that clip, for the best. I believe the pull request is actually still kind of sitting out there. Not sure why it hasn't closed. But that's going to do it for part 2 of the core modules. And we got another batch of core modules to get to next week for our New Year's special. And we are going to start off really hot with our VLAN segment. So if you remember back, I did an entire episode about how VLANs are more than just theory, and kind of went through the entire process of me finally getting them working. And it was a huge moment for me in my home lab journey, which is why I wanted to include it. But you're going to have to wait for next week's episode to get that clip. But until then, if you enjoyed this episode, definitely be sure to leave it a rating and review, and subscribe if you haven't done so already. And be sure to let me know what your favorite clip was, or if I omitted a clip that you wanted to hear and you didn't hear. Also be sure to let me know about that as well, either in a comment down below if you're on YouTube, or you can shoot me an email at contact@darkassassinsinc.com. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.